Okay, I need you all to give yourself just an ample amount of grace in this section because this is some trigonometry and pre-calc stuff, which if you haven't been in the class, I'm trying to condense a lot of information. My biggest advice to you, if you haven't been in a trigonometry class and you get to these questions on the ACT, circle it, skip it, and then come back to it at the end. See if you can figure it out, but if you can't, just guess. This is not worth your stress if you haven't had this math before. So there are three types of functions that fall within trigonometry, and those are sine, cosine, and tangent functions. If you have had a geometry class, then you're familiar with those terms. There's a lot more that goes along with them, but this is what the graphs look like. So notice that your sine and cosine graphs are both waves that are all together, and your tangent graphs are these separate little curves that are happening. Notice the difference between sine and cosine is that sine is going through the origin and cosine is not. So sine goes through that 0, 0, cosine does not, but they are the same graph, just kind of shifted over a little bit, while your tangent looks completely different. On the graph, so you might notice that these terms look weird. We have pi, negative pi, 2 pi, all the crazy stuff. That's a special unit called radians. So radians and degrees, remember we had to switch our calculators to this, are both measurements of a circle. This is me watering stuff way down. But know that 180 degrees equals pi radians. So if you're just looking, pi here is 180 degrees. That's just true for all of your graph. You can use these two equations to solve for degrees to radians. So here I've plugged in 90. If I take my degrees and multiply it times the ratio of pi radians over 180, then that will take my degrees and turn it into radians. So 90 degrees equals pi over 2. I can also do that if I have radians and switch it back to degrees, but it's always about this set ratio. But if you're just looking at your graph here, then know that around here is going to be 90, here is going to be 180, here is going to be 360. So that'll be true every time. If you just memorize the pi over 2 pi and 2 pi, you should be good. Other things to know, when we talk about amplitude, that's like the height or from the axis to the top of the wave. So this only happens in cosine and sine functions, and it's normally 1. The period is your distance from your peaks, or in a tangent function, it's like the distance between where it's crossing. It's just like the space in between. And for cosine and sine function, that distance is normally 2 pi or 360 degrees. And for a tangent function, it's normally pi. Remember, pi is 180. There are also, final fact we're going to look at, there are 3 more trig functions. They're reciprocal trig functions. You might have seen them on your calculator. But they are cosecant, secant, and cotangent. And that just happens when you take your normal functions and you put them under 1 in a fraction. So cosecant is sine under 1. Secant is cosine under 1, and cotangent is tangent over 1. And it's just, if we think of our SOHCAHTOA, it's just doing the opposite. So sine is normally opposite over hypotenuse. Cosecant is hypotenuse over opposite, and so forth. Y'all, I'm sorry. This is like a whole class worth of material that I'm trying to water down for you. This is just a little bit of information so that you at least know what you're looking at. But again, if you haven't taken trig, then don't freak out if you don't know how to answer it and just guess.